welcome to my first tutorial video on this channel. In today's video, we are going to look at a chemical equation, more especially a balanced chemical equation. And because of this video, we are going to look at what a chemical equation is. We are going to look at the importance of a balanced chemical equation. And lastly, I'm going to teach you a very easy technique through which you can balance a chemical equation. By the way, my name is Michael Warren. I'm a medical student and the principal tutor of Warren Science Academy. Welcome to Warren Science Academy. This year will simplify those various science concepts, making them easy, comprehensive, and interesting. Let's get. First thing we are going to look at is the definition of a chemical equation. Now, what is a chemical equation? A chemical equation is simply a representation of how various chemical species, it could be one, it could be more than one, and those chemical species are known as the reactant. How they react, or how they mix, or how even they break down to give us other chemical species known as the product. So we have reactant on one side and then we have the product on the other side. Let's take a typical example. Let's assume you take milk and then you mix it with chocolate, giving you tea. So on one hand you have milk and chocolate reacting or mixing. We call that the reactant, and the tea is known as our product. Usually in every chemical reaction, on our left hand side, on every chemical equation rather, on our left hand side we have the reactant, and on our right hand side we have the product. But this is not true in all cases. We'll look at those cases in a short time. On our left hand side where we have our reactant, and on our right hand side where we have our product. Now in this chemical equation we find out that hydrogen gas reacts with oxygen gas to give us our product, which is water. Still in this second equation, we have nitrogen gas reacting with hydrogen gas to give us our product, which is ammonia gas. This is our word product. So like I said, on every chemical equation, we have reactant on our left-hand side and the product on our what? Right-hand side. But this is not true in all chemical equations. For example, if you look at this reaction, we find out that in this forward reaction, we have nitrogen and hydrogen gas giving us ammonia gas. But for the backward reaction, ammonia gas dissociates or it breaks down to give us hydrogen and nitrogen. So for the backward reaction, ammonia is our reactant, while hydrogen and nitrogen are our products. So but we just typically say that we have reactant on the left hand side, which is not true, but products on our what? Right hand side. So in essence, a chemical equation is simply a representation of how various chemical species or species, which we call reactants, they form other chemical species or species which are known as what? The products. So we've looked at what a chemical equation is. Now we're going to look at the importance of a balanced chemical equation. We can say an equation is balanced when what we have on the left hand side of our equation is equal to what we have on our right hand side of our equation. If we have 50 grams of a substance on the left hand side, we should equally have 50 grams on the right hand side. So that makes the equation balanced. Now, why is it good to balance an equation, or why is it mandatory to balance an equation? Number one, a balanced equation obeys the law of conservation of mass. Now, what does that law state? The law states that mass can neither be created nor destroyed. Simple. You cannot create mass and you cannot destroy mass. In essence, if I have 50 grams of a substance on my left hand side, I should equally have 50 grams of the product on the right hand side. So it's as easy as that. So you cannot create mass and you cannot destroy mass. The second importance of a balanced chemical equation is that a balanced chemical equation can tell us the various elements involved. In this given equation, we find out that hydrogen and oxygen are the elements involved in this chemical equation or in the reaction itself. It can tell the state of matter of the various chemical species involved. In this chemical equation, we find out that the state of matter of hydrogen is in gaseous state, oxygen is in gaseous state, and also water produced is also in the gaseous state. In some other equation, we find terms like AQ, which means aqueous. We find terms like L, which is liquid, You find terms like S, which is solid, and G, which is used in this equation, is in what? The gaseous, is in the gaseous state. So you find terms like aqueous, liquid, S for solid, and G for the what? The gaseous state. The last thing is that a balanced chemical equation tells us the stoichiometry of the reaction. In chemistry, we define stoichiometry as the mass volume relationship, but it's beyond mass and volume. We can tell the mole, we can tell the volume, the molar volume, we can tell the mass concentration, the molar concentration, and a whole lot of concepts. So from this equation, we can tell that 2 mole of hydrogen gas react with 1 mole of oxygen gas to produce 2 molecules of water. So we can also see that we have 4 atoms of hydrogen gas, 2 atoms of oxygen gas, and still 2 molecules of water. So we can get various information. We can calculate the mass of hydrogen reacting with a specific mass of oxygen, producing a specific mass of what? Water. So this is the importance of a balanced chemical equation. And when you have a balanced chemical equation, you can simply go ahead to solve and get or derive various information from that balanced chemical equation. In this last part of this video, we are going to teach you how you can easily balance chemical equation. So I don't start thinking, should I add a 2, should I add a 1, should I add a 7? No, I'm going to teach you a very easy technique called the algebraic method. So in the algebraic method, we are simply giving alphabets to our various chemical species. We use A, B, C, D, E, W, X, Y, Z, depending on you. But let's use A, B, C, D to balance this chemical equation. So in this chemical equation, we have nitrogen gas, hydrogen gas, reacting to give us ammonia gas. But we find out that we have 2 atoms of nitrogen on the left hand side, and we have 1 atom of nitrogen on the right hand side, making it not equal. So also for our hydrogen gas, we have 2 atoms of hydrogen and 3 atoms of hydrogen. It makes the equation unbalanced. Now, how do we balance it? Using the algebraic method, we are simply going to give these various chemical species alphabet. So let's use A for nitrogen, B for hydrogen, and C for ammonia gas. So when you have done that, the first thing you do, you identify the element present in this chemical equation. By so doing, we will see that we have nitrogen, we have hydrogen. These are the only elements present in this chemical equation. So when you have done that, you then start with the first element, which is nitrogen. We have 2 atoms of hydrogen, 2 times A, we have 2A. Now this equal to sign, this sign is like an equal to sign, so simply take that as an equal to. On this side, we have 1 atom of nitrogen times the C will give us C. 1 times C will give us C. For hydrogen, we have 2 atoms of hydrogen times B will give us 2B is equal to, for hydrogen on the right hand side, we have 3 atoms, 3 times C will give us 3C. When we have done this, we have identified the element and we have used the algebraic method to find out what we have on the left hand side and also what we have on the right hand side. We then pick, when we have done that, we then pick any of the alphabet. Any, it could be A, it could be B, it could be C. Pick any of the alphabet, make it to be equal to any number of your choice, but I usually prefer 1. So let's start with A. Let A be equal to 1. So pick any alphabet of your choice, any alphabet of your choice, and make it to be equal to 1. It could be 2, but I prefer 1. When we have done that, you can pick any of your equation. It could be equation 1 or equation 2, but we'll start with equation 1 because we have A in this equation. So equation 1 says 2A is equal to C, and we've already taken A to be equal to 1. So this becomes 2 times 1 is equal to C, means C is equal to 2 because 2 times 1 gives us 2. So now C becomes 2. So let's keep this aside. So our last equation says 2b is equal to 3c. So 2b is equal to 3c, and c is equal to 2. So this equation becomes 2b is equal to 3 times 2. Numerically means 2b is equal to c. From normal math, we'll divide both sides by the equation of b, which is 2. We'll divide both sides by 2, both sides by 2. When 2 cancel 2, b is equal to what? 3. So now from calculations, a is equal to 1, b is equal to 3, and c is equal to 2. So I can then come back to this equation and write this entire equation as a is 1. In place of a, I'm going to put 1, but there will be no need for that. In place of b, I'm going to equate that to be 3. So b is 3, so I can write this as 3h2, and then c is 2, so I can write this as 2NH3. 2NH3. You can see that from this equation we have 2 atoms of nitrogen. On this side we also have 2 atoms of nitrogen. From this side we have 6, because 2 times 2 gives us 6. 6 atoms of hydrogen gas, and we have 3 times 2 is 6 atoms of hydrogen gas. So with this method you can easily balance any chemical equation, how big the chemical equation is. If you are new to this channel, don't forget to like and subscribe to this channel so that whenever I release any new video, you always get notified. And also don't forget to drop your questions in the comment section of this video. Till I see you in my next video, do have a wonderful time.